Hello, this is Ms. DB, and in this video we're going to go over how to do some of the problems from the Chapter 8, Section 3 worksheet on adding and subtracting rational expressions. So before we get started on the problems here, I wanted to review how do you add fractions. So this is going back to middle school, elementary school, and here's the steps to adding fractions. Step 1, make sure the bottom number, the denominators, are the same. Step 2, add the top numbers, the numerators, and put the answer over the denominator. And step 3, simplify the fraction if needed. Those are the exact same steps that we are going to do today. It's just that our denominators and our numerators are going to be algebraic expressions. They'll be polynomials rather than just a number. So there'll be an x or a y or something in there. So here's an example with like denominators. If you have the same denominator, you just go ahead and add the two numbers on top, the numerators, and then you simplify your result. So 2/4 can be simplified to 1/2. If you have different denominators, you need to find a common denominator first. The easiest way to do that is to figure out what are the factors of each one of these. So this is 3 is as simple as it gets, but 6 is 2 times 3, which means that if we multiply the first fraction by 2, both the top and the bottom, both the numerator and the denominator, we can change it to an equivalent fraction. So you probably remember doing that. So we would change 1/3 into 2/6. Now they're both the same. We have 2/6 and 1/6, and we can go ahead and add them together and get 2/6 plus 1/6 is 3/6. And then you simplify after that. This is just another example with that same problem. So, and here's the thing to help you remember. All right, so what we're going to do, now look at this one does not have any common factors. 3 is as simple as it gets, 5 is as simple as it gets. So the first fraction needs both the numerator and the denominator to be multiplied by 5, and the second fraction needs both of them to be multiplied by 3. So if they don't have any common denominators or common factors, then you can multiply them by each other to get a common denominator. And then you can go ahead, once you rewrite both of them with a common denominator, then remember you just add the numerators. You never add the denominators. So you get 8/15 for an answer. All right, so there's other methods of getting a common denominator, but we're going to move over now to your worksheet where we are going to do these same kind of problems, except you'll be doing them with expressions, algebraic expressions, rather than just numbers. So you can see on the worksheet there's a couple examples. These are just from your book. You can look in your book for more examples. There's also videos that you should watch before getting too far into this. So in this one, the first denominator is x plus 3. The second denominator is x plus 3. They are common already. So you can go ahead and add the numerators together. 3x minus 4 plus 2x plus 5. We're adding, so find any like terms, and that will be 5x plus 1. Note that that is a minus 4, and you need to make sure that you have negative 4 plus 5 when you add those together. Generally speaking, in these problems, you won't have to do that step of simplify at the end. These will be as simple as they can get. However, there is an additional step in adding and in subtracting rational expressions that we didn't have to do when they were just numbers, and that is figuring out what x cannot equal. And we've done this in this chapter already, but we cannot let x be -3 in problem 1a here, because that would make you get 0 as the denominator, which is not allowed, that's undefined. So you need to add that to your answers. Where or what can you not let x be? Okay, letter B, this one, x squared plus 2 and x squared plus 2, that's the same in both. Again, this time we're subtracting. The key thing to remember when subtracting is that you have to, this is like the distributive property, you have to subtract both of those numbers. So it's going to be minus 4x minus 4, not plus 4 here. So be very careful with that. Since these did have the same denominator, you can just go ahead and subtract them and then just name where what x cannot be equal to. In this case, x squared plus 2 equals 0. You would not, there is no real value for that. If you tried to solve that, you would get an I, you'd get an imaginary number. So there's no real values that we have to worry about. Usually, though, there will be something. All right, so in number 1 and 2, these are also common denominators. So all you have to do is the top. Now, there is 2 ways in Word to do this. You can just use parentheses as needed. So 1x plus 2x is 3x. And you can use the backslash key for division, and then in parentheses you can put the common denominator of x plus 1. And then don't forget that x cannot equal, in this case that would be -1, because if it was -1 we'd get 0 in the denominator, and that's not allowed, that's not defined. The other way to do these is to use, if you're using the most recent version of Word, or even the one from the last like 8 years, you have an equation button. You go to Insert and then Equations, and I need my, if I have this full screen, there's more options here. I need here we go. So I need this menu to come up here, and I can do a fraction, and I could write this as 3x. This looks really nice when you're done if you do it this way, and this is x plus 1. And then you would still add the x cannot equal -1 somewhere in there. Put that back over here. If you are writing these by hand, of course, let me get my pen tool, then you would just write 3x over x plus 1. All right, so moving on, you can do number 2 on your own. On these next examples, there is not a common denominator yet. So first there's a little review of how to find common denominators for polynomials. So the least common denominator is really the same as the least common multiple. So if they're just a string of monomials here, then you can say, well, let's see, the least common number part would be 6, because I need a 2 and a 3 as my factors. Then I have x to the third is the lower of the x's, and x to the fifth is the higher. You need the higher of each one. So I need the x to the fifth. And then y to the fourth, y to the third, you need the higher one, so you need the y to the fourth. So you have to take the highest of each exponent as your factors. So then you'd have 6x to the fifth, y to the fourth. A lot of your problems are going to be like B here, where you'll have to factor first. So for x squared plus 3x minus 4, we could factor that to x plus 4 times x minus 1. And for x squared minus 3x plus 2, we could factor that as x minus 2 times x minus 1. Now these two are the same. So our least common denominator would be one of those, x minus 1, and then we need one of each of the other parts, x plus 4 and x minus 2. So you know, if the same factor shows up twice, you only need to show it once. So 3 and 4 is just practicing finding the least common multiple. All right, so then the next thing is, here's a review of adding fractions like we already went over. And now we're going to look at adding rational expressions. In this example here that's on your worksheet, you can see that first you have to factor everything that you can factor. So the first fraction, x squared plus 2x minus 3, factored into x plus 3 times x minus 1. And the other one already had an x minus 1. So the least common denominator is, the first one has everything, it's going to be the x plus 3, x minus 1. So the first fraction has everything it needs. The second fraction needs the x plus 3 part. It already has the x plus 1, it needs the x plus 3. So the second fraction needs to be multiplied by x plus 3. So then we can rewrite both of our fractions as here it is here. Now they already multiplied through the 2x times x plus 3. You can do that now or you can do it later. But here they have x minus 4 over x plus 3 times x plus 1, or x minus 1, sorry, plus 2x squared plus 6x over x minus 1, x plus 3. Now that we have common denominators, we can just go ahead and add the top together, and then you will combine any like terms, and then this is how you will leave your answer. Then the last thing you need to do is say where or what can x not be equal to, and it could not be -3 or +1, because if it was either of those things, you'd get 0 in the denominator. Remember, to find that, you just set this little equation equal to 0 and solve it. So x cannot equal -3 and it cannot equal 1. All right, there's another example there, but let's go ahead and try a couple problems. And subtraction is the same exact thing, except you have to subtract, so there will be a distributive property part involved here. Everything will be subtracted. So number 5 and 6 I've already started for you. I've got a bunch of notes. You may be able to click in that little box even. I'm in pen method here. Let me get out of here. You may even be able to click in that box if you're using the newer version of Word and type what you wanted to in there, or you can just type it again. Make sure that if you are just typing without using the equation tool, that you are using parentheses around the whole denominator so that you it doesn't look like just part of it's being divided. All right, let's look at number 7. In number 7, we have x squared minus 3x minus 4 is one of our denominators, and x minus 4 is the other. Now, they're not the same, and what you have to do is factor the first one in order to get that to look, break it down into its factors. So let's see, I'm going to go back here and do my squared. So x squared minus 3x minus 4, that factors into my two sets of parentheses as, let's see, so we know we can put our x in our first part, x here and x here. And now we have to look for the factors of -4. So what are the factors of -4? We could do -4 times 1. We could do, let's see, what else could we do? We could do -1 times 4. Or we could do -2 times 2. We have to pick the pair of factors so that when we add them together, we would get -3. So the first ones were the ones that I want to use. So in here, I want to put -4, and over here, I would put +1. Now that I know what that factors to, I'm going to rewrite this with those factors. And I'm also going to think then, what does my second fraction need that it doesn't yet have? It has the x minus 4. See, it has that part. It needs the x plus 1. So you can do this using the equation tool, or if you're typing by hand like I'm going to do, then you can rewrite this as x minus 4, x plus 1, plus 3 over x minus 4. Now they're not yet common denominators, so I need to multiply that second one by something. The first one's good, I don't need anything for the first one, but the second one needs an x plus 1. And when you multiply, you have to multiply both the numerator and the denominator by that. So now what do we get? Now the bottom is the same on both of them. So the top is x plus 3 times x plus 1. The denominator, I'm going to write this all over the same denominator now, is x minus 4, x plus 1. And then I just have to simplify the numerator. So this would simplify to x plus 3x plus 3, remember you're going 3 times x and 3 times 1, over x minus 4, x plus 1. And then that finally will simplify to, let's see, x plus 3x, that's the same as 1x plus 3x. So that all simplifies to 4x plus 3 over x minus 4 x plus 1. And x cannot equal 4, and it cannot equal -1, because if I plugged either of those in, one of the factors would be 0, and 0 times 0 is 0, so, or 0 times anything is 0, so that would not be allowed. That would be undefined at 4 or -1. All right, let's look at a subtraction problem. That's a plus. Oh, here we go. Number 9 is subtraction. Let's look at number 9. In number 9, we have to find the common denominator because they're not common right now. So if I have x squared minus 3x minus 18, we can factor that. So I set this up, I put my x and my x, and then I need the factors of -18, that when I add them together, I'll get -3, the middle term. So -9 times 2 doesn't work. How about -6 times 3? Yes, because if I add these together, I'd get -3. So I put in -6 plus 3. Another hint is that the second fraction's denominator, or the other fraction's denominator, might be a good hint at what you will need to use for your factors. So the numerator is 3x squared minus 1. Now I'm going to write this as my factors. X minus 6, x plus 3. And then the second one was x plus 2 over x minus 6. I'm going to put that in parentheses. Now what does the second one need? It needs the x plus 3. So I'm going to multiply top and bottom by x plus 3. And now we have common denominators. They're both x minus 6 times x plus 3. So now I can go ahead and add the numerators together. 3x squared minus 1 minus, I'm going to put this like this, x plus 2, x plus 3. I use the square brackets because this whole thing is going to be subtracted. We're going to have to do a little work on simplifying that before we're done. And then the denominator is x minus 6, x plus 3. So the simplifying of this one is going to be a little bit more time consuming. The 3x squared minus 1 is good. We'll leave that. I'm going to leave the minus, and then I'm going to FOIL this together inside here so that I can see if I've got any like terms to add to my 3x squared and my minus 1 here. So I'm going to take, I'll use a different color here, first times first is x squared. The outer would be x times 3, so that would be plus 3x. My inner would be 2 times x, so that's plus 2x. And then my last times last, I guess I'll go back to blue, would be 2 times 3, and that would be plus 6. So I FOILed that together. This is all over x minus 6 times x plus 3. Now there are some like terms that I could have simplified there. The 3x plus 2x would be 5x. So I could have went x squared plus 5x plus 6. That 5 looks kind of funny. I'll try that again. That looks like a minus, and it's not supposed to be. Erase. Okay, good. All right, so now we have, I'm going to put back what I had. I had 3x squared minus 1 minus everything that we just simplified that to. Now, if you want, you can put a minus 1 and distribute a minus 1 through everywhere. So you could call this minus 1 times x squared, and then negative. Do I have too many minuses? No, that's fine. I had it right. Minus. There. And then you could do negative 1 times x squared, negative 1 times 5x, and negative 1. I'm just going to go ahead and know that if I have a negative in front, every one of these signs will change to the opposite. So now I have 3x squared minus 1 minus x squared minus 5x minus 6. And it's still over x minus 6, x plus 3. The danger of not writing the over x minus 6, x plus 3 every time is that half the time you might forget to put it back at the end. But if you're doing this, you know, you don't necessarily have to keep writing this if you want to just simplify the top off to the side and then put it back as the numerator when you're done. So now I can combine my like terms. I've got 3x squared minus 1x squared. That would be 2x squared. Let's see, the only x term I have is minus 5x, so I'll write that next. And then I have negative 1 and a negative 6. Negative 1 minus 6 would be negative 7. That's all over my common denominator of x minus 6 times x plus 3. Now this took up some considerable space. If you're going to do this by hand, you may want to hit enter a few times. I left quite a bit of room, but not enough, obviously, for my pen tool to write this. And then I would still have to say that x cannot equal 6 and x cannot equal negative 3, because then I would get a 0 in the denominator, and that's undefined. So there's how to do a couple of your problems. There's 12 altogether, but like I said, I just did a couple of them, so you have a little fewer less to do on your own. And let me know if you have any questions. If you have trouble factoring and you just want a quick double check how to factor, send me a quick email and I'll help you out. Thanks a lot and have a wonderful day.